All right, just a couple of thoughts. One that's sort of deeply cosmic and another one that is fascinatingly disturbing, I think. But you'll be the judge of this. Consider a couple of fundamental facts that has been gleaned in the past 60 years. That the ingredients, if you had asked your chemistry teacher 50 years ago, once you looked at that mysterious chart of boxes that sat in front of your class, the periodic table of elements, where did those elements come from? The chemistry teacher would actually not have an answer for you. They'll say, well, we dig them out of the earth. That's not where they come from. It took modern astrophysics to determine the origin of the chemical elements. We observe stars, we know what goes on in their center, they explode, laying bare their contents, and what we have discovered is that the elements of the periodic table, that which we are made of, derive from the actions of stars that have manufactured the elements, exploded, scattered their enriched guts across the galaxy, contaminating or enriching gas clouds that then form a next generation of stars populated by planets and possibly life. And so, when you look at the ingredients of the universe, the number one ingredient is hydrogen. Next is helium. Next is hydrogen, helium, oxygen, carbon, nitrogen. Those are the top ingredients in the universe. So you say, well, okay, that's kind of cool. Well, and you look at Earth, because we like thinking of ourselves as special, we say, oh, we're special. Well, what are we made of? Well, what's the number one sort of molecule in the body? It's water. It's water. Well, what's water made of? H2O, hydrogen and oxygen. Hydrogen and oxygen. In fact, if you rank the elements in the human body, with the exception of helium, which is chemically inert, useless to you for any reason other than just to inhale it and sound like Mickey Mouse, you can't die from helium unless that's all you breathe. Number one in the human body is hydrogen. Matches the universe. Number two is oxygen. Matches the universe. Number three, carbon. Matches the universe. Number four, nitrogen. Matches the universe. And for each of us, the fifth element, other, is the same in both places. Okay? Other. So, we learned in the last 50 years that, of course, not only do we exist in this universe, it is the universe itself that exists within us. And had we been made of some rare isotope of bismuth, you would have arguments, hey, we're something special. But there are people who are upset by that fact, saying, well, that mean we're not special? Well, I think it's special in another kind of way. Because when you look up at the night sky, it's no longer we're here and that's there. It's that we are part of that. And that association, for me, is actually quite enlightening and ennobling and enriching. In fact, it's almost spiritual, looking up at the night sky and finding a sense of belonging, given what we've learned about the night sky. And so now we have ourselves. Now, are we alone in the universe? We're made of the most common ingredients there are. And our chemistry is based on carbon. Carbon is the most chemically active ingredient in the entire periodic table. If you were to find a chemistry on which to base something really complex called life, you would base it on carbon. Carbon is like the fourth most abundant ingredient in the universe. Isn't that rare? You can make more molecules out of carbon than you can all other kinds of molecules combined. So if we ask ourselves, are we alone in the universe? It would be, in spite of my diatribe about UFOs, I tell you in the same breath that it would be inexcusably egocentric to suggest that we are alone in the cosmos. The chemistry is too rich to declare that. The universe too vast. There are more stars in the universe than grains of sand in all the beaches of the world. There are more stars in the universe than all the sounds and words ever uttered by all humans who have ever lived. To say we're alone in the universe. No, we haven't found life outside of Earth yet. We're looking, haven't looked very far yet, Galaxies this big, we looked about that far. But we're looking. And how about life on Earth? How is it hard to form? Just because we don't know how to do it in the lab doesn't mean nature had problems. So it may be, given that information, that given the right ingredients, which are everywhere, life may be inevitable, an inevitable consequence of complex chemistry. If that's the case, we look around our own solar system, we look at Mars. All the evidence suggests that Mars was once a wet, fertile place, an oasis. There are dried riverbeds and floodplains and river deltas and meandering rivers. It's all bone dry now. Something bad happened on Mars. Some knobs got turned in its environment that left it the way it is right now. Some bad knobs got turned on Venus, too. Runaway greenhouse effect. You saw the clip on that. 900 degrees Fahrenheit on Venus. Some knobs got turned there, too. People say, why spend money up there when we spend it? Because up there we might learn about down here, okay? I don't want a runaway greenhouse effect here. Venus is the best example in the solar system of a planet gone bad. Let's learn about that first. So, it turns out we learned that asteroid impacts, when they hit, can cast rocks in the surrounding areas into space with escape velocity, so they never come back to the planet from which it was launched. If Mars was wet and fertile before Earth was, as all evidence suggests, and if Mars had life before Earth had life, it is possible for there to have been bacterial stowaways in the nooks and crannies of the rocks that were cast into space. There's some hardy bacteria that we already know exists on Earth. Survives extreme temperatures, pressures, freeze-dried, reconstituted, radiation. The hostile environment of space would be nothing to some of these bacteria. It may be that life on Earth was seeded by bacterial stowaways on rocks that were cast free from Mars. This is a plausible scenario that's called panspermia, the transference of life from one planet to the next. If that's the case, that makes all of us descendants of Martians. I wanted to alert you in advance. Now, let me give you a disturbing thought. A fascinatingly disturbing thought, and we'll leave you on that note. If you look at our closest genetic relative to human beings, it would be the chimpanzee. We share like 98+% identical DNA. We are smarter than a chimpanzee. So let's invent a measure of intelligence that makes humans unique. Let's say intelligence is your ability to like compose poetry, symphonies, do art, math, and science, let's say, okay? Let's make that as the arbitrary definition of intelligence for the moment. Chimps can't do any of that. Yet we share 98, 99% identical DNA, okay? The most brilliant chimp there ever was maybe can do a little bit of sign language. Well, our toddlers can do that. Toddlers. So here's what concerns me deeply. Deeply. Everything that we are that distinguishes us from chimps emerges from that 1% difference in DNA. It has to, because that's the difference. The Hubble telescope, these grand, that's in that 1%. Maybe everything that we are that is not the chimp is not as smart compared to the chimp as we tell ourselves it is. Maybe the difference between constructing and launching a Hubble telescope and a chimp combining two finger motions as sign language, maybe that difference is not all that great. We tell ourselves it is, just the same way we label our books optical illusions. We tell ourselves it's a lot. Maybe it's almost nothing. How would we decide that? Imagine another life form that's 1% different from us in the direction that we are different from the chimp. Think about that. We got 1% difference and we're building the Hubble telescope. Go another 1%. What are we to they? We would be drooling, blithering idiots in their presence. That's what we would be. They would take Stephen Hawking and roll him in front of their primate researchers and say, well, this one is like the most brilliant among them because he can do sort of astrophysics in his head. Oh, isn't that cute? Little Johnny can do that too. Oh, that's so nice. Oh, in fact, Johnny just did that. Let me get it. It's on the refrigerator door. Here he is. He did it in his elementary school class. Think about how smart they would be. Quantum mechanics would be intuitive to their toddlers. Whole symphonies would be written by their children, and like I said, just put up on the refrigerator door the way our pasta collages are on our refrigerator doors. So the notion that we're going to find some intelligent life and have a conversation with it? When was the last time you stopped to have a conversation with a worm? Or a bird? Oh, well, you might have had a conversation, but I don't think you expected an answer, all right? So, we don't have conversations with any other species on Earth with whom we have DNA in common. To believe that some intelligent other species is going to be interested in us enough to have a conversation? They'll look at our Hubble telescope and say, oh, isn't that quaint? Look at what they're doing. So I lay awake at nights wondering whether simply we as a species are simply too stupid to figure out the universe that we're investigating. And maybe we need some other species, 1% smarter than we are, for which string theory would be intuitive, for which all the greatest mysteries of the universe, from dark matter, dark energy, the origins of life, and all the frontiers of our thought would be something that they would just self-intuit. I'm jealous of that possibility because I want to be around for those discoveries. Thank you all.